So this is multiple choice review problem number 15. And what we are given is the static friction between a box and a ramp is 0.5. So right away I see this word static. So I know this is going to be use of S. The angle is 30 degrees and the box is placed at the ramp. And they want to know, will it accelerate? Will it have constant velocity? Will it not move? So what the big question is this value of static friction high enough or great enough to stop the box from moving? And we're not even given a mass, but let's wait and see what happens. Let's write it out and see if we have enough information. So we have this box of unknown mass at 30 degrees. We know the coefficient. It says static, so we have no velocity, but they want to know, will it move? So acceleration really is that value at something that will cause it to move or not? So this problem is going to be a little bit different. We're not going to cancel out in Newton's second law. We're not going to count out acceleration because we kind of want to see what's going to happen. If I make my free body diagram, and I'm going to count going up the slope or to the right as a positive. I broke down my weight into the portions or my components of how much of the weight is in the y direction and how much of it's being affected into the x direction. So my next step always, even when I really don't know what's going on, I'm going to hurry up and just get to my diagrams and my forces. So I do Newton's first law and I have my positive static, the weight of the object wanting to slide down the hill, the portion of it, and then we're going to leave in acceleration this time because that's what I'm kind of looking for. Is there a value there? Or is it not going to work out? I know static friction can be broken down into its components of the texture, use of S, which they gave me, and how much weight is pushing down. So I now have this portion. My equation is this. So I need to know what f of n is. And the only way I can find that is going over here to the y direction. And I can subtract the portion of the weight from the normal force. And here it's not moving up and down. So I am going to put that one to 0. So the normal force is equal to the portion of the weight that is in the y direction, which is the cosine of it. So now, let's bring that value over into here. And this is going to be y, the cosine. And again, it looks like I can't solve everything, but we need to remember, and notice I indent things when I'm adding in a new equation, that really F of W is the mass times gravity. So if I put that in, whoops. All of a sudden, I find out that mass doesn't matter in this problem. The mass of the box doesn't affect me at all. It's all about the coefficient, and how big the angle is what's going to affect me. And I actually know all of these values now. Whoops, it's 10. And it's a cosine of 30 minus 10 meters per second squared. 30 and that is equal to A. And this is going to work out, and we're just going to save some time. So A does actually have a value. It is going to be negative. So the negative tell me that, because I said this is positive, we said that up above in our problem. So that negative does mean that the value is actually going to slide down the hill. If this had been a positive value, it would have stayed. But since it's negative, it will actually move down, and that causes my answer to be, it will accelerate down the ramp.